Fundamentals of wave. What is wave? A wave can be described as a disturbance that travels through a medium, transporting energy from its source to another location without transporting matter. To make it simple, wave involves the transport of energy without transporting the matter. We are going to discuss about how wave is produced, how many ways to classify wave, what are the important features or characteristics of a wave, how to calculate the speed of the propagation of a progressive wave, how to describe a wave in a graphical method. How wave is produced. Wave can be produced by an oscillating or a vibrating system. Types of wave: mechanical wave, electromagnetic wave, stationary wave, progressive wave, transverse wave, longitudinal wave. Electromagnetic wave does not require medium to transfer energy. Made up of oscillating electric and magnetic fields perpendicular to one another, all electromagnetic waves are transverse wave. Example of electromagnetic wave: light wave, gamma rays, and radio wave. Mechanical wave requires a medium to transfer energy from one point to another. Made up of vibrating particles of a medium, mechanical wave can be a transverse wave or a longitudinal wave. Example: sound wave, seismic wave, and water wave. Stationary wave. A stationary wave is a wave where the profile of the wave does not propagate with time. Stationary wave is produced when two identical progressive waves moving in opposite direction in the same medium are overlapping in the condition which both waves have the same speed, frequency, and amplitude. Progressive wave. A progressive wave is the one that allows propagation of energy through the medium as wave continuously travels in one direction where the amplitude is kept constant. Progressive wave can propagate through a medium as transverse wave or longitudinal wave.
There is two waves, which is transverse wave and longitudinal wave. So for the transverse wave, as you can see the animation that we have given, the wave moves up and down. So the highest point of the particle of the medium is crest, and the lowest point of the particles of the medium is trough. Next, come to our definition of the transverse wave. Transverse wave means the particle of the medium move perpendicular in the direction of the wave. As you can see the diagram on the right, there is an example of a transverse wave. What is meant by perpendicular? Perpendicular means a line meeting another at a right angle or 90 degree. Beside it, there is a diagram shows how the perpendicular looks like. Now, we will learn about the characteristic of transverse wave. So, for the first characteristic of the transverse wave is consists of crest and trough. For the second one is it have no pressure variation. Why there is no pressure variation? Because there is no compression occur. For the third characteristic of transverse wave is can be propagated through solid and surface of liquid but not in gases. And the last characteristic is there is no change in the density of the medium because the transverse wave always move constantly. There is three examples of transverse wave. The first one is water wave, the second one is light wave, and the third one is radio wave. Four of the picture that I have given is all about the three wave. For the longitudinal wave, there is compression and reflection occur. So what is means by compression and reflection? So compression means the part that the particles of the medium get closer, and reflection means the part that the particles of the medium far apart. Now is the definition of the longitudinal wave. Longitudinal wave means the particle of the medium move parallel in the direction of the wave. The picture shows on the right is a longitudinal wave. So, what is means by parallel? Parallel means to be similar or equal to, or to go or extend in the same direction. The picture below shows how the parallel looks like. Next is the characteristic of longitudinal wave. So, for the first characteristic of the longitudinal wave is consists of compression and reflection. For the second characteristic is there is a pressure variation throughout the medium. Why there is pressure variation throughout the medium? Because there is compression occur. The third characteristic of longitudinal wave is can be propagated through solid, liquid, as well as through gases. And the last characteristic of the longitudinal wave is there is a change in density throughout the medium. because when it is compression, the density will become higher, and when it is rarefaction, the density will become lower. There is only one example of longitudinal wave, which is sound wave. The similarities of the transverse wave and the longitudinal wave is both transfer energy without transferring matter. So this means the particles do not move along with the wave. For the second one is both produced by vibration or oscillation. The third one is both propagate through vibration or oscillation of particles of medium. And the last one is both have amplitude, wavelength, wave speed, period, frequency, and obey the equation V equals to F lambda.
Now let's talk about the characteristic of wave. We can differentiate a wave by its amplitude, frequency, and period. What is a wave amplitude? Wave amplitude is the maximum displacement of particles of a medium from its equilibrium position. In other words, amplitude is the distance between the equilibrium position and the peak. Next, what is the wave period? Wave period is the time taken by the wave to complete an oscillation. A complete oscillation may refer to the time taken for the particles of the medium to move from crest to trough and back to crest, or from trough to crest and back to trough. Then, what is the wave frequency? The wave frequency is the number of complete oscillations made by a vibrating system or a particle in 1 second. The SI unit for frequency is Hertz, where 1 Hertz is equal to 1 complete oscillation in 1 second. So these are the equations to calculate the period and the frequency of wave. Then here is the formation of equation to calculate the speed of wave. We start from speed equals to wavelength over time, which is equals to lambda over t. Arrange it, you will get 1 over t times lambda, where the 1 over t is also equals to the frequency of wave. Therefore, speed of wave, v equals to frequency times lambda. Last, here is 2 simple questions. Question 1. A wave of frequency 120 Hz has a wavelength of 5.0 meter. What is the speed of wave? You can pause the video here and try to do it by yourself. So here is the solution. The question asks to find the speed of wave, so we're using the equation of v equals to f times lambda. Given the frequency equals to 120 and the wavelength is 5, so v equals to 120 times 5, which is equals to 600 meter per second. Next is our question 2 with a graph. From the graph given, find the amplitude and the wavelength. From the graph given, we can observe that the highest displacement of the wave from the equilibrium position is 4, so the amplitude of the wave is 4 cm. And the distance between two peaks is 12 cm, which is from 0 to the 12, so the wavelength of the wave is 12 cm. That's all from me for my part.
Now, I'm going to talk about sketch and interpret wave graphs. First of all, you can see a diagram with a lot of words, and that is how you describe a wave. You can pause to read it. Next, I'm going to introduce types of graphs. The first is graph of displacement against time, and the second one is graph of displacement against distance.